In today's lesson, we're going to talk about how to identify conic sections when given an equation in general form, which an equation in general form is written like this: ax squared plus by squared plus cx plus dy plus e equals 0. So I've got all the terms on the same side of the equal sign. And really all I need when I'm identifying conic sections are all squared terms on the same side of the equal sign. So the first thing that we're going to be looking for, if the equation has an x squared or a y squared, or the equation, and actually I'm going to highlight this whole thing. Does it have an x squared or a y squared, or does it have an x squared and a y squared? Like, are there two squared terms? If it has only one x squared or one y squared term, like they're both not squared, then it's a parabola. So then x squared will open vertically if you have an x squared. If you have a positive x squared, it opens up. If you have a negative x squared, it opens down. If you have a y squared, your y squared will open horizontally, and these are just good little notes to write in, little reminders. If you have a positive y squared, it's going to open to the right. If you have a negative, it's going to open to the left. So now let's move on. If your equation has an x squared and a y squared, we're looking at is it a hyperbola, is it an ellipse, or is it a circle? Well, first, do x squared and y squared have the same sign, or do they have different signs? If x squared and y squared have different signs, so it's like x squared over something minus y squared over something, or y squared over something minus x squared over something, something like that, then you're looking at a hyperbola, okay? Which, if you have something like this, it will open sideways. If you have x squared minus y squared, it'll open up and down. If you have y squared minus x squared, so that if the x squared is negative, it opens up and down. If the y squared is negative, it opens left and right. So now let's go back to, what if x squared and y squared have the same sign? So x squared and y squared have the same signs. Well, now we're looking at, it's either going to be an ellipse or a circle. But, and I'm going to switch because I don't have any more left. If x squared and y squared have the same coefficient, you're looking at a circle. X squared plus y squared, you're looking at a circle. If they have a different coefficient down here, that might look something like x squared plus 3y squared, right? Those are different coefficients. You're going to have an ellipse, right? And it can be elongated horizontally or vertically. So that's what we're looking for. And you can refer to these as we go through our 4 examples on the next page. So in these 4 examples, it says to classify each conic section and justify your reasoning. So that's what we're going to do. In this first one, I have x plus 3 squared equals 4 times y minus 8 squared minus 64. Well, I need all squared terms to be on the same side of the equal sign. So I have this x plus 3 squared, and what I'm going to do is I'm going to move this term over by subtracting it. So minus 4 times y minus 8 squared equals negative 64, and I could leave it just like that because it doesn't matter if I move that negative 64 over or not. I could, but I don't have to. So what I do see is that all the squared terms are on the same side of the equal sign. This is subtraction right here. Because it is subtraction, that tells me that this is a hyperbola. That's all I need to do. I don't need to look at anything else. One of those squared terms is negative, which means this is a hyperbola. Let's move on to number 2. Number 2, 36x squared minus 9 equals negative 36y squared. What I'm going to do is move this negative 36y squared over by adding it, which I wrote 3 plus 36y squared. I'm going to add that to both sides, so I get 36x squared plus 36y squared minus 9 equals 0. So now this is addition. So if I look at my flowchart graphic organizer thing, I know that it has an x squared and a y squared, and I know that we're adding. So I'm left with, I can eliminate parabola and hyperbola, and I'm left with it's either a circle or an ellipse. Because the squared terms have the same coefficients, right here, I have a 36 and a 36, that tells me that this is a circle. So it's addition, and then we have the same coefficients. And then because it's addition and we have the same coefficients, that tells me that this is a circle. Let's move on to example number 3. In example number 3, I need all squared terms to be on the same side. So x squared over 9, I'm going to add the y plus 5 squared over 81, and I'm going to leave it set equal to 1, right? So I move this over by adding it. So now I've got everything on the same side of the equal sign. And what I notice is that it's addition, or what else I can notice is they're both positive. So that's something else that we can look at. They're both positive. They do have different coefficients. This is essentially the x coefficient is 1/9 and the y coefficient is 1 over 81. So there are different coefficients. This is our justification here. There are different coefficients, right? 1/9 does not equal 1 over 81, which means this is an ellipse. Let's move on to the last example. Now in this one, what I'm going to do is x minus 3 equals 5y squared minus 2y. I can already tell that I only have one squared term. But what I'm going to do is I'm going to go ahead and move all the terms to one side. So I'm going to subtract 5y squared and I'm going to add 2y. And it's going to look like this. Negative 5y squared. Let's see, I'm going to write plus x plus 2y minus 3 equals 0. So I can see right here that I have only one squared term. There's no x squared term. And because I only have one squared term, I know that this is a parabola. And that's all you're doing today is identifying conic sections. So make sure that all your squared terms are on the same side of the equal sign. Then you can work through your graphic organizer flowchart to determine, is this conic section a parabola, circle, ellipse, or hyperbola? And that concludes today's notes. I hope it was helpful.